Our process starts with ingot aluminum, which we purchase from any one of the large aluminum companies. This ingot, along with scrap from various parts of the operation, is first melted in this furnace. A unique aspect of our process is the fact that cans after use can be salvaged and also remelted for subsequent fabrication into cans again. Molten aluminum pours from the discharge of the furnace into the casting machine. The molten aluminum is solidified between the surface of the wheel and a metal band and emerges from the underside of the wheel as a continuous aluminum strip. We are casting here at the rate of approximately 3,000 pounds of aluminum per hour. This strip, which is approximately 900 degrees Fahrenheit in temperature, must now be reduced in thickness down to gauge. The first step is this hot rolling operation. The strip enters the mill 3/4 of an inch in thickness and emerges 3/16 in thickness. This white milky stuff you see splashing around is lubricating oil. It is necessary to prevent sticking of the aluminum to the mill surfaces and to keep the rolls themselves cool. The second rolling operation is the gauging operation. In this case, the strip is rolled to 1/8 of an inch in thickness and is coiled in 700-pound coils, as is being done here, or is blanked into aluminum slugs or discs for the subsequent can forming operation. This is a finished lid strip coil. The gauge is checked and the strip is carried over to the blanking press. Before blanking, it must be immersed in a thin lubricating oil. Pure aluminum, as we use here, is extremely sticky, and any tool or punch must be thoroughly lubricated to prevent sticking of the aluminum to the tool. This continuous casting operation is unique in the world today. The blanking press floats on the line. As the slack loop in the aluminum strip builds up, It triggers the starting switch of the press, and as the press chews up the strip, it pulls the slack loop down to trigger another switch and thus shut itself off. Scrap emerging from the press is normally chopped up into small pieces by the guillotine cutter and returned to the furnace. The slugs are conveyed to an annealing furnace where they undergo 1 hour at 900 degrees Fahrenheit to soften them for the subsequent extrusion process. This is an overall view of our annealing furnace. The drop test, here shown in slow motion, is a good way to determine whether a slug has or has not been annealed. You will note the higher degree of elasticity on the unannealed slug on the left. After annealing, the slugs must now be tumbled and deburred. After tumbling and deburring, they are immersed in a lubricating solution and dumped into another trommel where they are dried. On completion of this process, they are ready for extrusion. The coils of lid strip also must be annealed before rolling down to lid gauge. The strip in these coils is of course 1/8 of an inch in thickness and must be rolled down to 14 thousandths in thickness before being stamped into lids. This is the strip rolling operation. Five passes through this mill are required to bring the strip down to gauge. And again you will note the milky rolling oil which is used to prevent sticking of the aluminum to the rolls. In this operation, we are punching out lids from the lid strip. The strip is being fed into the punch press and the lids blanked out. Each can, of course, must have its lid, so the lid operation is just as important as the can making operation. After punching, the edges of the lids are curled on these wheels to permit stacking. Next, a latex sealant is applied to guarantee a pressure-tight seal between the lid and the can. A slow-motion camera freezes this operation for us. Note the white milky latex being applied to the rim of the lid. On the left we have the lid as blanked. On the right you'll notice the edge has been curled in and the latex applied. The latex is then cured for 1 hour at 200 degrees Fahrenheit in this oven. The operator is laying out the lids for inspection and packing. We pack lids in these reusable containers. Now for the actual can making process. Slugs are dumped into the hoppers above the impact extrusion presses. A feed mechanism brings the slugs down into the press itself, and the can is extruded. Note that the slug is carried into the die cavity and then hit with a punch, the aluminum literally squeezing out alongside of the punch to form the can. Again, the high-speed camera, operating at 600 frames per second, freezes the operation for us. The slug is inserted into the die cavity. The punch comes in, it meets the slug, hesitates momentarily, applies the pressure, some 400 tons, and the aluminum squeezes out, forming the can. The machines on the left of the press are trimming and flanging the cans. Again, extreme slow motion view of this action. We use these slow motion studies to assist us in the design of many components of this production line. The collar of scrap, which is cut off, is returned to the furnace for remelting. After trimming and flanging, and before the decorating and internal lining operation, the cans must be thoroughly degreased and the surface properly prepared by etching so that they will receive the inks and the lacquers. This machine is a washer which performs that function. We are looking down along the side of the washer where the cans enter to the discharge end where the cans are emerging. The next operation is to decorate the outside of the can. This is done by dry offset rotary lithography. 4 colors are individually applied to a mat or blanket. Here is one of the colors being applied to the blanket on the lower drum. The 4 colors are then transferred from the blanket to the can in one pass. The high-speed camera freezes this action for us. After decorating, the inks must receive a preliminary set in the oven shown at the top of this picture. And emerging from this oven, they are carried to the internal lining machine. The nozzles are going into the cans from the right and thoroughly spraying the entire interior surface. We use a vinyl lining very similar to that used in the standard tin plate beer can. The final operation is this baking oven. The cans receive a 10-minute bake at 400 degrees to thoroughly set the internal vinyl lining and the external inks. Inspection is next, with the finished cans being dumped helter-skelter into reshipping cartons for transport to the brewery. We are now in the filling area at the brewery. Cans are dumped into this unscrambling device. This simple but ingenious machine lines the cans up into rows and gets them into single file for transport to the filling operation. Because we are filling under sterile conditions, the cans must first be steam sterilized before filling. The filling operation itself is conducted under aseptic or sterile conditions such that the normal pasteurization process can be eliminated. In that way, we can can a true draft beer. The cans are emerging from the filler and being carried over to the closing or capping machine. The star wheel on the upper left is carrying covers over, putting them on the cans, and the closing turrets are spinning the covers on tight. From the filling and closing operation, the cans are carried through to an X-ray height detection unit where the low fills and overfills are rejected. The final step is packing the can in 8 packs, similar to our 12-ounce 6-pack. Because of its relatively low speed, 150 cans per minute, the machine is hand-fed. Note also that the packing of the 8 packs into the mother cartons is a manual operation. Automatic machinery cannot be justified at these speeds. And so, for the first time in history, aluminum ingot has been converted into a finished beer can in one integrated automatic process. A beer can competitive with the tin plate beer cans on the market today.